Welcome back to our Ubuntu server series. Today we're talking about the way Ubuntu handles UDEV, Upstart, and firewalls. Now, it specifically handles these individual things in unique ways that I know when I started using Ubuntu Server, I had to figure out the Ubuntu way of doing them. So I thought a nugget on explaining how Ubuntu handles these individual things might be beneficial. So let's dive right in. We'll start with UDEV and we'll finish with firewalls. First off, we'll talk about UDEV. Now, what is UDEV? Well, basically, it is the way that you define specific events for actions on your system. Now that's a horrible definition, I guess, so I'll just give an explanation. For example, a lot of times if you plug in a USB drive, it will mount as different devices. It might be SDD or dev SDD, one time, and the next time it might be dev SDE, all depending on what's going on in your system at the time you plug it in. There are times when you want to write specific rules that force like one particular USB drive always to mount on dev SDH or something like that. And that's where UDEV comes into play. It helps define specific actions based on kernel events like plugging in a USB drive. This is a pretty complicated procedure. You can write rules that do specific things, like when you plug in a scanner or when you do anything. Anything that the kernel recognizes as an event, you can have UDEV do something while it happens. Unfortunately, sometimes UDEV can cause problems in the way that it does things. And this is where I first learned of UDEV, because my server created a UDEV rule that specified a particular Ethernet card with a particular MAC address was going to be ETH0. And so when I replaced that faulty card, I could not get my new card to be ETH0. It kept telling me that it was ETH1. I'm like, no, ETH0, I pulled it out. Why isn't it there? So I had to learn that UDEV had conveniently reserved ETH0 for that particular card that I had originally installed. And that's something that you run into when you clone machines too, because you install it on one machine, and then you clone the operating system to a new machine that gets new MAC addresses for the NICs, and all of a sudden none of your, you don't get Ethernet 0. Now you all of a sudden get Ethernet 1 or Ethernet or ETH2 or ETH3, that sort of thing. So UDEV is convenient, however, it can cause some headaches. And there's two main directories where configurations for UDEV live. There is this libudev rules, and I realize that my V's and my U's look very much the same, and I apologize for that. But just know that UDEV, this is a V at the end. All right, libudev rules.d. This is where the system files are stored. These are rules that the system comes installed with by default. Don't edit these. Okay, there's a bunch in there we're going to look at in a second, but you do not edit these. This is just where they live by default. Libudev rules, that's where the rules live, but we don't edit them there. Etc. udev rules.d. This is a folder. These are user files. These are what we edit. If we put a custom file, now creating custom UDEV rules is way beyond the scope of this nugget. However, if you do decide that you want to do custom UDEV rules, this is the place that they're stored. You store them inside this folder. What we're going to do is go in there, and I'll show you how you can delete automatically generated rules for your network cards or block rules from being created at all. But this is where we do things. Okay, this is where we're going to actually do stuff. The reason that we're going to do things in here is this is just a general fact about UDEV. The user files that are created in this etc. folder, they take preference or precedence over system files. So in order to disable one of the existing rules, you could delete it, but that's not the proper way to go about it. Basically what you do is create an empty file with the same name in this folder, and then that empty rule will supersede the system rule that is in place. We're going to actually do that so that you see how it works, but that's the definition of why we're going to use folders or files in this folder. All right, so let's go to the command line and check out UDEV. Okay, here we are on our desktop system. I'm going to SSH into our server. So here we are on our server, and I'm going to go into etc. udev rules.d. Now this again is the user place, like this is where we would add or modify rules in the etc udev rules.d folder. And in here you're going to see that there are some files. First of all, let's read the readme because that's what it says to do, right? In the very name. Okay, so write your own rules in this directory. That's what I talked about. And pick a number higher than the rules you want to override, and yours will be used. And you can copy the file from lib udev rules and edit it. So anything that we copy from there, it will override the files in lib udev rules. Does that make sense? If you want to edit something in this, again, we never touch the files in lib udev rules. We would copy that file and make changes, and the ones in the etc udev rules.d folder would override that. So that's actually what we're going to do, but I want to show you what's in there first. That readme just basically said what I showed you in that last slide. So we have persistent cd rules, persistent net rules, and VMware SCSI udev rules. The one that I want to focus on is this. Okay, so let's look at it. You'll see here it's empty, which is a little bit unfortunate because I believe this is due to the way VMware handles MAC addresses. It doesn't recognize it, so it doesn't make the persistent net rules for VMware workstation created servers. So I actually copied one that I'm going to show you what it would normally do, but it does give us a little bit of information. Entries are automatically added by this file, so 75 persistent net generator rules. However, you're also free to add your own entries in here. You'll notice that in our folder there isn't a 75 persistent net generator, right? So that must mean that it lives in the lib udev rules.d folder, and these are all the system files that exist there. And sure enough, persistent net generator rules lives in the lib udev rules. Now we can't delete this, but what if we were to change our Ethernet ports? First of all, I'll show you. This is my home directory. This is a 70 persistent net rules that I copied directly out of my server. I copied it out of my server in action, not our VM server here, but my actual server, to show you what normally is created. Normally we get this, okay? This looks familiar because this is, talking about where the stuff is stored. Please ignore this. This is actually an older version. My server is actually running Ubuntu 10.04, so ignore the actual things about where the file's stored. It's actually stored in lib udev rules.d. Okay, that is where it's stored. But these are the things I want you to focus on. These are the entries that don't exist on our system, but do exist here. And this basically says that this MAC address will always get this named device. And the same with this MAC address will always get this named Ethernet name, device name. So if we were to remove these cards and add new cards, they would automatically start populating new. We would get ETH2 and ETH3 instead of ETH0 and ETH1, which causes lots of problems because there's lots of different programs that specify ETH0 or ETH1 for them to function normally. So that's a problem for us. And the best way to, like if you clone a system, the simplest way is just to delete this file out of the etc udev rules.d folder because it will be generated on boot again. However, if you don't ever want to experience this problem again, you can simply create a file in this folder and you can call it 75 persistent net generator rules. And now if we look in our folder, we have a file there called persistent net generator rules, which means the one inside this folder won't even be run. This is not going to be executed now because we have it. We have a similarly and exactly same named file in our etc udev rules.d. So this will basically stop this program from running altogether, and it will no longer populate this persistent net rules rule with specifics about our hardware. Now, this isn't necessarily a bad thing. Maybe we always want to make sure that the same card is the same device name so that ETH1 and ETH0 don't like swap around when they boot up. However, again, knowledge is power. If you're having an issue, or if you're cloning computers constantly and you start running into the problem where your Ethernet cards aren't working, this is the way that you can disable one of these rules. If you deleted this rule from the etc udev or from the lib udev rules folder, yes, that would also disable it, but that's not the proper way to go about disabling it, right? Because then what if you want it back? It's gone for good. So you create an empty file in this folder, and that will disable the rule. And then we can actually just delete that rules file, and now it won't specify ETH1, ETH2 when we boot up with new hardware. It'll just create them starting with ETH0 and then ETH1. So that's basically UDEV. That's how it works. Again, I'm not going to go into creating UDEV rules because that's way beyond the scope of this nugget. But this is the way that it functions. So you know where the rules are read from. The system rules are read, but anywhere in the etc UDEV rules.d folder, these override the system ones. So if you create an empty one here, you can disable this. If you wanted to change, like just modify one of these, you would copy this instead of creating an empty one, you would copy this file to this etc udev rules.d folder, and then you would make modifications here, and this would supersede what's in here. So your changes would be active, but you never actually touch the files in here. And the reason, well, one, yes, because it's not the proper way to go about it, but if there's a udev update, like your system updates install an updated version of UDEV, it's going to create these rules again. So if you keep your empty files or your modified files in the etc UDEV rules.d folder, it's upgrade persistent, right? It's upgrade proof. So when a new version of UDEV puts new rules in this folder, your rules are still going to be the ones that are in place. Okay, hopefully that makes sense. That's UDEV. And now we will go and talk about Upstart. The next thing on our list of how Ubuntu does it is System 5 init and Upstart. Now, this is System 5 init from the Unix world. I've also heard it called sysv or sysv init because this is a Roman numeral, V for 5, but it's easier to say sysv rather than sys5, I guess. I don't know, but I usually call it sysv init, which is improper as far as grammatics go, but it is what it is. Anyway, this is basically the way that Linux handles startup programs, like what programs start when the system boots up. And there's been a change, and this change started way back like in 2006 when Upstart was first introduced. Now, the difference is with System 5 init, every process goes one after another, and the next process can't start until the previous process has completed. So that's really slow. Upstart allows us to start all of these processes, these startup processes, at the same time. So we don't have to wait for one to finish before the next starts. It's not just a list of one after another. They can all start at the same time, making boot up time ridiculously faster. Okay, so that's the reason Upstart is a much more efficient, much better way of handling startup scripts. But it is a change to the old way. I say, remember how I was so upset about that DNS change that Ubuntu did? Well, yeah, it's a better way to go about doing DNS, I realize, but it was a change, and we had to change the way we do things. What's really nice about Upstart is, yes, it's a change to the old way, but it's done better because Upstart is fully backward compatible with the System 5 init system. It's really cool in that we get all the advantages of Upstart, but we don't immediately have to learn how to use Upstart. We can slowly change things over to the Upstart initialization scripts, which do this parallel starting of the scripts, and we don't have to worry about, my program isn't compatible, it still uses sys5. Well, that's okay because System 5 still works. Upstart is just a way that we can transition. I expect that everything is going to be Upstart before too long. It's like I said, it's been since I think 2006 that Upstart was initially introduced, but because of the backwards compatibility, it's not a big stress. Okay, some important directories to know. Etc init is where the Upstart configurations files live. So if your program is Upstart compatible or is starts up with actual Upstart configurations, that's where the configuration is stored. Etc init.d is a folder that contains the System 5 initialization scripts. Many of these are just symlinks to the Upstart system. So that's how they've maintained backwards compatibility. Is yes, they're still stored in the etc init.d folder. However, those that have been converted to the Upstart way of doing things are just symlinks to the Upstart system. It's pretty slick. And then this is more for historical information than anything else. Etc. RC, and then the X stands for a number.d. So if we're doing run level 2, which is what Ubuntu uses by default for most things, it represents all the startup scripts. They're actually symbolic links to startup scripts in this folder, and they start with either capital S or capital K for starting or stopping individual services when entering that run level. Again, run level stuff is also a little bit outside of this particular nugget because we're just focusing on the Ubuntu stuff. However, this is good to know that, RC 1.d, RC2, RC, wow, I don't know what I did there. RC2.d, RC3.d. So all of those contain folders or contain links to the scripts that live in the etc init.d. However, Upstart, everything that Ubuntu releases by default has an Upstart configuration file. Those are stored in the etc init folder. Okay? You just need to know that that's the difference, but since it's backwards compatible, there's not a whole lot to learn other than Upstart is ideal, and if you're going to start and restart processes, you're going to be able to use a program called Service, which maybe I should have made that another. Service allows for Upstart manipulation. So if you want to restart Apache, for example, you can type service apache2 restart, and it'll use that Upstart configuration file to restart the service properly. Okay, so we'll just briefly look at that because there's not a lot you have to learn. I just wanted you to know how Upstart and System 5 are kind of merged together in Ubuntu. Okay, so very quickly, if we head over to etc init.d, remember this is the sysv or System 5 startup scripts, and we see here are a bunch of the different programs that can start up, for example, like Apache 2. But if we look, a lot of these are symbolic links that actually point to libinit upstart job. And based on how it's called, it actually knows that to restart like network interface is an upstart job. But if you type network interface restart, it actually runs upstart job, telling it to do the network interface restart, and it bases that on the network interface.conf file. That's really an upstart file right here. So by looking back, let's go back to that directory. You can see that a lot of these are in the process of being converted to Upstart. Anything here that's pointing to Upstart job, this script, we know that that's already fully Upstart native. And then something like Apache up here, Apache 2, well, let's look at that real quick. We can see that this actually uses a standard start-stop, just like it uses a standard System 5 start-stop. So when I said that it was completely Upstart compatible, I was actually wrong about Apache 2, but that's the great thing. You don't need to know because Upstart is backwards compatible with System 5 init, and it's just seamless to the end user. So I can actually, if I want to restart Apache, I can restart it that way, or I can type sudo service apache 2 restart. And it does the exact same thing, whether it's an Upstart job or a System 5 init, because they're so backwards compatible. It's been done really, really well so that from the end user's perspective, you don't even have to know. But the reason that it's good for them all to be converted to Upstart jobs, remember we talked about in our slide, is that Upstart jobs, when they start on the system boot, they do it parallel, so they don't have to wait for the next one to finish before starting the next one. It's not like once number 1 finishes, number 2 starts, and number 2 finishes, number 3 starts. They can all run at the same time, which means for a much, much faster system boot up. Anyway, that is the difference between Upstart and System 5 init, but because of the compatibility, you don't really even have to know what's going on behind the scenes, but I like you to be informed. I like you to know what Upstart's all about. And that, actually, we're going to finish off this how to do it the Ubuntu way with our slide on UFW. Now, I have a confession. As I was preparing to talk about UFW, I had always assumed that UFW stood for Ubuntu Firewall, but I was very wrong. It stands for Uncomplicated Firewall, which is really cool because it's perfectly descriptive. UFW is great because if you have used Linux in the past, you know that IP tables, which has replaced IP chains, is a very powerful, however very confusing and very complex way to manage the firewall rules in a Linux system. And it's unfortunately kind of easy to make mistakes that make your firewall not as useful as you want it to, and sometimes to lock yourself right out. So what UFW does is it allows you to use simple command tools to manipulate the firewall that is under, behind the scenes, it is still IP tables, but it's just very, very convenient. Now, there are configuration files that you can edit. They're stored in etc UFW. There are also some files that are created in var lib UFW, but just like with those udev rules, you're not supposed to touch these by hand, right? These are created when you use the command line tool that we're going to look at on the command line. But the configuration files that you are allowed to, for lack of a better way to put it, you're allowed to manipulate are in the etc UFW folder. Okay, this is where the configuration files live, but you probably won't even need to touch them because UFW is very uncomplicated. Okay, it's important to note too that UFW is disabled by default, and maybe that's so that you're not locked out of your system, but it is installed by default. It's just disabled by default. And in order to get a really good grasp of how to use UFW, a simple sudo UFW help will give you a great list of how to go about doing things. That's actually what we're going to do, and then I'm going to do an example of how simple it is to configure UFW for things that you want it to do. All right, so let's go back to our command line one last time and check out UFW. All right, here on the command line, just like I said, I recommend that you do sudo UFW help, and it gives you this really nice set of simple rules. It's a lot simpler than a man page even, right? It just shows you the commands that you would want to use. We're going to do a couple. We're going to, first of all, you always have to type sudo. In order to use UFW, you need to be root, and that should be obvious why. I mean, obviously it's, the system firewall. We have to be root to be able to manipulate that. But sudo UFW, let's first type status. And it says that it is inactive. Again, by default, it's inactive. Let's do sudo UFW, just like up here, enable. It's going to give us a warning. It's going to say, this may disrupt existing SSH connections. Are you sure you want to proceed with the operation? I'm going to say yes. And I'm only going to say this because I know that it actually won't disable an existing SSH session. I won't be able to start another SSH session because if we look at sudo UFW status verbose. So just like right here, status verbose, we're going to do that, and it's going to show us what our firewall looks like. So the status is active. It's being logged in the system log, and the default is to deny incoming traffic and allow outgoing traffic. So that means right now that on the server I would be able to get out, however things would not be able to get in. And let's see if that's true. So here I am on, again, now this is on our workstation. I'm going to try to connect to CBT server. Now I know Apache is running. We just restarted it a few moments ago, but it's not letting any traffic into the server. So it's being blocked. We know that that is actually working now, right? Our firewall is working. Let's try disabling it to see. Sudo UFW disable. Now the firewall is stopped and disabled on system startup. Let's see if we can go to our server now. Look, bam, bam, I'm a working web server. So all of a sudden we can connect simply by doing that. Now there's a lot more we can do. Let's do UFW enable again. Yes, we want to enable it. And now let's do the help again just so we can see that screen. Let's take a look at the different applications that UFW is aware of. Even if we don't know ports and specific things like that, we can still use UFW. UFW app list, and it's going to give us a list of the installed applications that it knows about. So it knows that Apache is installed, right? So let's see. Right now we should not be able to get in, correct? Yep. it's hanging because we have the firewall on. But what if we did sudo UFW allow Apache? Okay, it's saying that the rule is added, and a rule is added for version 6, IP version 6. So it's added a rule to allow that connection, and we can see that if we type status verbose. It's going to say now connections on port 80 for Apache and for Apache version 6 are allowed from anywhere. So we've allowed it. Now, oh, sure enough, finally it resolved, right? It tried and tried and tried. As soon as we opened up that port, it allowed us, or as soon as we opened the firewall, it allowed that connection. And so now we're able to connect, even though our firewall is on, right? Our firewall is active, but we've opened up the ability for Apache to connect. And the nice thing about it when we enable and disable is that, let's see if we can scroll up here. When we enabled it, it not only enables it and makes it active, but it enables it on system startup. So whatever setting we leave here, it actually saves it persistently from reboot to reboot. So that's really awesome. And UFW is by far the simplest way that you will manipulate firewalls, I promise. If you ever tried to use IP tables, it's very confusing, very complex, and this just makes it simple if all you need is to protect your system and allow access to the different things that you have installed. You can do a lot more with UFW, but for this nugget, I'm not going to go into in depth on all the different things that we can do. However, know that it is very simple and it's powerful for what it actually does. Okay, so that is UFW, how you use it. We can actually disable it again if we want. So the firewall is now stopped and it's disabled on system startup, so it's not going to start up on us. Okay, and we should still be able to get to our server just fine. Yep, it loaded just fine. Look, I'm a working web server. Let's go back to our slide, make sure that we covered all the different things that Ubuntu does in a unique way, and then we'll move on to our next nugget. All right, that wasn't terribly painful, right? We covered UDEV. We talked about those rules and how you disable a rule and where you would put your own custom rules if you wanted to learn how to create those custom rules. We talked about Upstart. We didn't talk too much about it because really the only thing that I wanted you to know is that Upstart is the new way for starting programs because they can do it parallel on startup for a much faster system. But since it's compatible with the System 5 init, it's really not important that we know the differences on how to do it, just to run a server. And then we learned about UFW, the uncomplicated firewall that Ubuntu provides for us to secure our system. It's really nice, really simple, and with that, I hope that this has been informative for you, and I'd like to thank you for viewing.